All right, we are back with part 4 of the final project of the Stellar Robotics 2018 CAD class. We're here with our drivetrain, which is starting to take shape. So we've got a few things left to do, which I mentioned at the end of the last video. We've got to get wheels and pulleys in here so that we can figure out the spacing of the drive rails. And then we've got to model the shafts, we've got to model the belly pan, and then I forgot to mention, but we've got to go through and we've got to lighten everything. So I'm going to blow through. I'm going to blow through the wheels and the shafts and stuff as quickly as I can. We'll throw the drive. We'll probably do the belly pan in with the lightning, which I'll probably split into 2 separate videos. So, in the interest of time, because we're already well over 2 hours, let's get going here. So let's go to Vexpro's website. We're just going to use under motion, yeah, wheels and hubs. I think we're just going to use their Versa wheels. I think we can get a 4-inch version with a hex bore. I could be wrong. Oh no, we can only get. That's obnoxious. I guess for convenience we could do Coulson's. That would be pretty much the same thing. I just don't want to have to use a hub because I don't want to have to deal with the parts in this assembly. We'll pick wheels next season based on whatever we would think we need. All right, so I'm going to go back to motion, go to wheels and hubs again. We're going to use a Coulson wheel just to save ourselves some modeling time. The Coulson doesn't get quite as much traction, but they're more wear resistant. Probably more teams use Coulson wheels than the Versa wheels anyways. We've used Coulson wheels before. All right, so we want 4-inch diameter. We'll do 1.5 inch wide. And yeah, we'll do the hex bore ones. We could do the really thin ones, but those are a bit thin for my taste. If we were trying to save space in our drivetrain and we didn't care much about traction, you could do those, but we're going to go ahead and go with 1.5s. All right, so go to CAD files, Coulson Performa 4 by 1.5 half-inch hex download. All right, and we already got the pulleys, so we can kind of drop all this stuff in there. All right, show in folder, cut, go to Google Drive, CAD, fall, drivetrain. Paste, refresh. All right, so we don't need any of the, no, we need the pulley. We don't need the gears. We don't need the sim motors, step files. Let's delete those out. All right, going back to here, let's import. Let's import the wheel. Should come in with appearances already, I think. It doesn't. Great. Okay. I just want to color this so that it looks right. So this like halfway. So the black starts here. This stuff's black. So here's what we're going to do. I'll show you how to color this. We're going to kind of do what we did with the sim motor. So let's first of all let's figure out what the weight of this is so it's accurate. 4.5, so 0.53. So let's we'll set the appearance to gray. Ooh, that's pretty dark. Is there a light gray? Yeah, there is a light gray. Okay, light gray will work. A little darker than it imported as, but all right. So let's right-click on this in the browser. Go to iProperties. Go to Physical. Update. Change this to 5.3. It was actually close. 0.53 pounds. Click Update again. Click OK. All right. So now what we're going to do. Actually, I set the material wrong. So this needs to be black because the middle of the wheel, the hub is black plastic. So I set it to this glossy black color that I like to use. Then what we're going to do is I'm going to click this face here. I'm going to hold Control, and I'm going to click all the faces that I want to be gray. And this other side is different, so I'm just going to make the whole thing gray, even though it's actually split. Half of it's gray, half of it's black. All right, so then with all those selected, I click the drop down. I can go to L, go to light gray. All right, so now the wheel looks, you know, kind of like it does. That's not actually the right one, but no, that's not it either. I don't know. Anyways, I'm wasting time. Okay, so let's place a work axis somewhere in the middle. Give that a save. Close it. All right, let's open, do our sprocket. This will be easier because it's all black. Okay. Delete the sketch. This is aluminum 6061, I believe. We'll place a work axis, and this will be glossy black. And because it didn't change color, go to solid bodies, do my little clearing overrides thing. Resize that, make that not stick out so far. All right, give that a save. Close that. Okay, so let's get wheels in here. There's going to be a ton of spacers between the wheels to keep everything spaced out and keep things from rubbing against the drive rails and stuff. We're just going to place offsets in our mates, and then if we do a fastener video where we go through and add the fasteners, then I'll go in and add all the correct spacers. So let's place in 6 wheels. I want to turn them the other way. Okay, so I turn these. I just want this like half black, half gray section facing out, just because this side looks a little weird. It's just me being particular about how it looks. Okay, so let's constrain the axes of each wheel to the axes of the bearings. So something like that. Actually, did that flip it around? That flipped it around. That's not what I wanted. Okay. That to that. And then I'm going to click aligned and then undirected and then apply. So that flips it the other way, the way that I turned them. Alright, so and they're clipping into the part, but that's okay. We'll move them and set the offsets later. Alright, so next let's drag these in off a little bit. Okay, and like I mentioned before, we are going to have to notch this slightly. It looks like very slightly. We'll take probably a 1/4 inch off and notch that out. And then actually once we do that, these end parts will be done, and we'll go ahead and color them just so that we know. Actually, let's do that now, just so we can get that out of the way. So let's open this. Actually, no, we can't do that. Sorry, I'm losing my mind because I don't actually know how wide this needs to be. So, alright, so basically there's this little ring, and I really don't know what the ring is for, but there's a ring. And so we've got to space this off from the spacer will rest on this bearing, which is kind of inside of this hole. So from the bearing to the inside of the drive rail is 1/8 of an inch, because it's just the material thickness, because the bearing's just kind of up against what would be the inside or the outside of the plate. So we need 1/8, and then I suggest we do another 1/8 to here, so we do a 1/4 inch between the wheel and the face of the bearing. So let's do a constrain, a mate, there to there, and let's do a 0.25. See how that looks. Yeah, so there's a nice gap in there. You want your wheels as far to the outside of your drivetrain as you can get them, but you don't want them to rub, because obviously that adds a lot of friction, and that's not good. So let's do this 1/4 inch spacing. Actually, let's actually not do it that way. Let's do a flush. So if I change the spacing on one wheel, these other two will change, and then we'll do the same thing over here. So let's do a flush from here to, we got to get the perfect angle to be able to pick this. Zoom in, and there we go. All right, so now I'm flushing the wheels to each other, and actually I could do the inside. Why did I not do the inside? I'm an idiot. All right, let's do this the smart way. I just used Control-Z to undo that. Let's do this on the inside. Alrighty. Okay, then I'm going to switch back to a mate, and then I'm going to do the same thing with a 1/4 inch spacing here. Now you make sure you got to pick the inner race. So 0.25, and then switch to flush and flush that face to that face. Press enter. Oh, great. Come on. There we go. That face to the first wheel again. Okay, so now both of the wheels are kind of like positioned left to right, and they're aligned with their axis. I think we're probably going to have to move the drive rails out because we got to get 2 pulleys in here, and I think, yeah, it'll interfere with the bottom flange. So let's go ahead and put 2 pulleys on this shaft, and there'll be 1 pulley on this shaft and 1 pulley on this shaft. We got to do some spacing things there, but that'll become clear. All right, so let's grab our pulley. Let's place 2 of them, and then we'll rotate and place 2 on the other side. And then, actually, we're going to need 1 here, and 1 here, and then 1 there, and 1 there. Okay, so let's constrain that to the center line of the wheel. Now we've got to figure out what actually contacts. So I think there's this hub in the middle, and that will go against that, I believe. And we just want to make sure that any of these like flanges and ridges are not interfering, and it looks like they are not. You can easily check for interferences, so I can go to Inspect, go to Analyze Interference, define set 1, pick 1 part, define set 2, pick the other part, click OK. No interferences. But if I had parts that were like running into each other, like if I had like this clipping inside of that part, and then I analyze interference, define part 1, define set 2, click OK. It'll tell me, it'll highlight in red all the places that are overlapping, tells me what the volume is, tells me how many actual separate interferences there are. It's a super useful feature. Okay, so next, this is going to go inline as well. Okay, that was not great. Okay, so then I think these hubs, the hubs are just flush with the edge, so I can just go to assemble and constrain that hub to that hub. And then if I'm worried about these overlapping, I don't think they are, but let's go to Analyze Interference. Got no interferences, but if I do Analyze Interference with this and the sheet metal, obviously there is one because it's running into it. So let's measure from here to here. So this is what's kind of annoying. It's just over ½ an inch. Like it's so close. It's so close. And it's actually close enough, like 22 thousandths. Like it's 22. So my point is, we can move this out ½ an inch, or we can move it out an inch. If we move it out an inch, we're going to have way too much room. But if we move it out ½ inch, we're still going to have an interference. It'll be, this flange will be like rubbing against this. But what we're going to do is we don't actually need this flange to be quite this long. Like we want it to be, but we can take 1/8 of an inch off of this. So that's what we're going to do. And actually, that's pretty common on this design and drivetrain. We've done that. We did that last year with Arcturus' drivetrain. The inner drive rail lower flange is slightly notched. We'll notch it starting here, and we'll just take out probably 1/8 of an inch. So let's edit this, and we need to change this whole pattern to move these in. So this needs to be 4.5, and this we'll just set it to that, so it'll be 4.5 as well. Finish the sketch. Those holes will move in. Save. Let's go ahead and leave this open because we're going to notch it here in a second. This is also done with that. This guy. All right, update. Okay, so we move those in. Because we moved the holes and these are constrained to the holes, when we click this update button up here, it updates everything and everything moves inwards. So now we just have a very, very small interference here. just a very small one. So we're going to fix that by notching this. So let's go to that part. Alright, so let's create a sketch on the bottom. Let's project this edge here. It's going to be a rectangular, oops, it's going to be a rectangle. Turn off construction geometry, add a rectangle. Alright, so now we need to project here because we got to measure from, actually we don't need to project it, it'll do it automatically. Okay, so dimension from here to here, that's going to be the depth of our cut, which is going to be 1/8 of an inch. And then from here to the end of the part is going to be, we just want this to be even with the channel that's wrapping around. The end channels are 2 inches. But because this part is inside the channel, we got to subtract the material thickness, so it'll be 0.0625. And then we're going to do the same thing on the other end. We'll just click on this first dimension to make them equal. Alright, so finish the sketch. And we'll use the cut feature. Click OK. So that cuts it. Next, we're gonna radius this just very, very slightly. So we're gonna add a corner round. We're gonna do a point. We're gonna do a 0.5 inch radius. We'll click on 0 selected. We'll pick these edges. Oops, not that. I just held Control and clicked on it to deselect it. Okay, so then that smooths that out a little bit. Let's give that a save. Close that. Go back to our drivetrain model. And you'll notice there's our notch. And no notch on this side, so we got to go up and click Update, and then the notch appears. Okay, so now we should have no interference. We should have a small gap. Perfect. Perfect. Okay, so looking great. All right, so now let's go ahead and constrain these other two in where they're going to go, and then we'll do the other side. So let's go back to Assemble, go to Constrain. Let's constrain the axis to there. Apply that, and constrain this axis to here. Apply that. All right, now this guy is going to butt up against the wheel. However, we can't attach this one to the wheel because there's going to be a belt that runs from this pulley to this pulley, and we have a belt that runs from this pulley to this pulley. So this pulley actually has to be out even with this pulley. So we'll just flush this pulley to that pulley so they'll be lined up, and then we'll just fill this gap with spacers later. Alright, so let's go to Constrain. Let's go to Flush. Let's get an angle on this pulley where we can see the hub. Flush that to that, and that to that. And apply. Okay. And then so like this gap in here between the bearing and this thing, we'd fill that with spacers. We'd fill this gap with spacers. We fill this gap with spacers, that gap with spacers, that gap. You know, so there's just, like I said, there's a ton of spacers that get involved here. But basically, and then we'll just have a hex shaft that runs through there, which we'll model shortly. Okay, so this is perfect. That's the way it needs to be. So now, if we wanted to, we could go in and model the hex shaft, but let's finish constraining these, and then we will do that. We're also going to, before we do that, we're actually going to notch this out so that these end pieces are actually completely done. All right, save. All right, go to constrain. Let's, I just placed it inside, gosh darn it. Why are you doing this? I don't understand. You can flip them. You can flip it back and forth the other way by clicking the arrows. This part's symmetrical, so I don't really care which direction it is. Normally I do, but in this case I don't. Okay, so let's constrain the hub to the wheel. Press Enter. Let's constrain this hub to the other hub. Press Enter. Let's constrain the front to the wheel. And that, flush that to the middle hub. Okay. All right, so now inside, inside, double, double, outside, outside. Everything's a mirror image of itself. Okay, so yes. All right. Okay, so now we need to notch this. So we're gonna notch it from there to just whatever that is, so 3.5 inches wide, and it'll be an inch in from the end. So let's we're only gonna do this on the bottom. So let's create a sketch on the bottom here. Press S to bring up the sketch tool. Click. All right, let's project this. We'll just notch a 1/4 inch out. It's not super critical. We just want to make sure there's enough clearance for the wheel. So rectangle. So we'll use a collinear constraint to line up the bottoms of these. Oh, it already did it. Okay, did it automatically. So that's okay. All right. So dimension from here to here will be an inch on both sides. Click and make the 2 dimensions equal. And then we said this was what, 3.5. Same. Click the other dimension and press enter. Then the height is going to be 0.25, and because they were lined up, they're both the same. Okay, so now finish that sketch, and let's do a cut, and we'll select the 2 regions, and then click OK, and it cuts it through the thickness. Okay. Alright, so now we need to round the corners. We're going to do a 0.1 inch radius. Click on 0 selected after we change that. Pick those. Alright, this part's actually done now, so I'm going to change the color to blue, which is going to make our assembly look really weird, but we know if a part's colored that it's done. So when we look at our assembly, we can see, oh, the drive rails are done, or the end channels are done, but the drive rails are not. If we can look in here, we got this little kind of overlap, but that's okay. We'll have to duplicate this notch in the drive rail in the belly pan as well, but that isn't a big deal. Okay, so, yep, plenty of space between the wheel and the end channel. It's beautiful. Alright, this is shaping up nicely. So let's model shafts, and then we'll end this video. In the next video we will tackle the belly pan and the lightning holes, which I probably not going to get done tonight. Probably got to do those another day. But let's get the shafts modeled. Okay, so we know that the face of the, so that's going to be a hex shaft, but we've got round bearings. So we're going to have to do that whole thing where we turn the end of the shaft down. Basically, that keeps the shaft from sliding out one of the bearings. So we know that the front of this bearing is up against the inside of this like drive rail here. Well, it's actually the outside of the drive rail. So we know if we go to the measure tool from here, and then the other side, so that's where one of the hexes can start, and this is where the other end of the hex is going to be. So 4, and that's 3/16. So if we go to advanced settings and increase our precision, but yeah, 4.1875 is 3/16. So we know we'll have 3/16 of hex, and then we'll have a 1/2 inch round that goes in this side, and a 1/2 inch round that goes in this side. And the shaft here, 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 and here will all be the same. So it'll be 4 copies of one shaft. So let's model that shaft. So let's go new, standard. So we're going to start with a polygon, hexagon. So we've got to dimension its width across the flats is a 1/2 inch, and oops, F9 to hide those dots. It can rotate still, so we're going to use a vertical constraint just to constrain one of those lines to be vertical. All right, next we're going to, actually this, right. Actually, hang on a second. Is that right? That's right. Okay. Anyways, I was just evaluating whether this is the same way we designed it in the past or not. I think it is. It doesn't make a difference if it's not, but okay. Finish the sketch. Extrude that out. That was 4.1875. I'm gonna make it symmetric. Now, because I aligned this hexagon on the origin, I can go to the origin and turn on the z-axis. That will give us our center line. All right, so now we got to model the round boss on either side. So let's create a sketch on here. This will be a circle that is a 1/2 inch in diameter. We'll just press the E key to extrude. It'll be 0.3125, which is the overall width of the bearing. Then we'll rotate around the other side. Press S for the sketch tool. Place a sketch on the end. We'll do another 1/2 inch round. Then I'm going to press the E key to extrude, and we'll do the same thickness. So, okay, so there we go. This will be aluminum. Oops, aluminum 7075. Hate that color. Aluminum flat. All right, so then we're going to chamfer the ends of these just to take off that sharp corner. It's going to do a chamfer, not a radius, a chamfer. We've never actually done a chamfer before, but we'll click that edge. It works just like a fillet, except it's a square, kind of an angled cut, 45-degree angle. The distance will be 0.05. That's good. All right. Looks good to me, so let's give that a save. Give it the next number in the series, an 8. All right, so now the shaft for the gearbox is going to be exactly the same, just longer. So we're just going to do a save as on this, and then we'll just make it longer. So we need to know how long the hex is, and we know the bosses will be the same because the bearings are the same. So from let's grab the measure tool from here, which is where the front face of this bearing is, and we need to get this front face of this bearing, which is where the hex will end. So it'll be that. So 5.1825. So this is kind of a weird number. It's not quite fractional, but it's easy enough. 5.1825. All right. And actually, what I usually do on these is I actually shorten this by maybe 0.005. So we're going to subtract 0.005. I'm just editing the length of the extrusion. So I just subtract 0.005 from that. It's just that way when these bearing blocks are put in here and they're tightened, they don't squeeze the shaft and put side load on the bearings. So you want a little bit of slough in the shaft is okay. And actually 0.005 you won't even be able to notice. It'll just make it so it's not tight in there. It doesn't add drag and doesn't wear out your bearings. Okay, so 5.1825 was what we're looking for, so we need to do a save as on this and give it a new number, which is 9. Give that a save. Okay, so let's edit extrusion 1, and our length is going to be 5.1825, or I'm sorry, not 8125. Give that a save. All right, so let's place in our corner shafts, and then we'll place in the gearbox shafts in the actual gearbox assembly itself. So let's place some of those down. So constrain. We'll constrain the centerline axis to the bearing. I'm going to use undirected and apply. Apply. I'm going to constrain these. Whoops, wrong button. To the outside, pressing enter after each one. All right, so next what I'm going to do is constrain this surface to here. You know, actually, hang on. Before I do this, I'm going to Control Z. I'm going to undo that. I'm actually going to do this with an insert because that'll be cleaner. Less constraints. So you have to pick one of these edges and then just to the bearing. Trying to get in the habit of using the insert constraint more often because it just saves a ton of mouse clicks. I've gone basically 8 years of doing Inventor and like just pretty much never used the insert tool, and just like within the past couple months I've tried to start using it again, or I've tried to start using it period, and it's making my life wonderful. Okay, so I'm going to open this gearbox assembly. We'll put the gearbox shafts in the actual gearbox assembly itself. Come on. There we go. Okay, place that. Place the shaft there. And I actually have to turn off this gear because I can't actually constrain this. So I'm going to right click on the gear and turn uncheck enabled. It'll turn it translucent and you can't click on it, which will help us constrain. So I'm going to go to the constraint tool, go to insert, grab one of those edges to the edge of the bearing and apply. Okay, and then I can go over here in the browser and find the part that's green is the one that I disabled. So right click on the green part and go down and check enabled, and it'll pop back up. Now the hexes are not lined up. We talked about this in the Gearbox project. There's really no reason to line the hexes up. You'll just waste time, waste processing power of the computer every time you update. There's no reason to line those up unless you're doing like a super nice photorealistic render and you want it to look exactly like it would in real life, in which case I would say, yeah, line them up. Okay, same thing with the gear teeth. Like, I mean, if the gear teeth are clipping into each other, don't bother trying to line those up. Okay, close out of that. Give that a, yeah, it needs to save. We'll give it an update, although I don't think it needs it. We can see that the shaft is flush. It's in the bearing, everything's centered. The shaft is going through. So there would be spacers in here. There'd be spacers in here, there'd be spacers in there, so that you'd fill all the gaps in the shafts with spacers. Basically, the round shoulders, so first of all, the round bearings are stronger. So that's why we used round bearings is in as many places as we can. The only place we couldn't is in the middle here, because you couldn't put a round bearing on a hex shaft. You wouldn't be able to get it on. But basically, that little shoulder... And when I say shoulder, I'm talking about this lip here, right? This little like tiny little lip here, these 4 corners or these 6 corners, basically. Basically, that shoulder keeps the shaft from coming out in this direction, and then the shoulder on this side keeps the shaft from coming out in this direction. So it's kind of just sandwiched between the two. But as soon as you undo these 4 screws that hold this bearing block on, you can pull the bearing block off, and then the shaft can pull out, which is kind of the whole point of doing that arrangement. Typically what I do is I model a belt to go in here. I'm not going to do that for this case because it really is not necessary. Not a lot of teams do that. I typically do it for my own stuff. We usually do it on Stellar, but for the sake of time, I'm not going to bother doing that for this project. Okay, so next time what we have to do is we have to add in the belly pan, notch, model it, add holes to it, notch out for the gear. Then we're going to go through and lighten everything. That's probably going to be a long video. I'm not going to try to tackle it tonight. It's getting pretty late. But I'll get that up as soon as I can, you know, depending on my schedule. So this should get you guys started. So this is pretty much it. I mean, this is, if you... with the addition of the belly pan, if you went and laser cut all these parts and made it, this would work. This is a functioning drivetrain. You know, there's some nice features like encoder, you know, mounting for encoders and things for autonomous mode that you would want to add. Obviously, you'd want to take weight out of it if you could. But this is a really good start. This is a better drivetrain than the KitBot. We've ran it for several years. You can use different sizes of wheels. You can use different gearboxes. This frame is stronger structurally than the KitBot. I don't know how it is on weight. Actually, we can go up here, right click on this, go to iProperties, go to Physical Update. So we're sitting at 28 pounds right now. So I believe it's heavier than the KitBot. That being said, we also haven't lightened it. That being said, it's also quite a bit stronger. Actually, wait a minute. I think the KitBot's like 35, so maybe it is lighter than the KitBot. it's going to be close either way. Like there's not going to be a significant difference because they're fairly similar. But anyways, this is a step up from the kit bot in terms of strength and efficiency. There's a lot less drag in the system and everything. So, yeah, thanks for watching. Tune in next time.